Yes, Aditya, you can start now.
Okay, sir. So, hello everyone. My name is Aditya, and I study at Triple IT Sri City in the Computer Science branch. And today we are going to cover the chapter of equilibrium. And equilibrium is a very important chapter when it comes to chemistry because you can see an ample amount of questions that have been asked from this particular chapter. Now, there are two types of equilibriums, chemical equilibrium and ionic equilibrium. Both these chapters are done in your 11th grade, chemical, ionic, right? So we will try and cover as much as we can in this session when we are trying to solve some PYQs related to this thing. So just before we start up the questions, a very brief that what is equilibrium. So what happens is when we have some reactants and we try to make some products. So what happens is initial reactants are a lot compared to what the products are. So our entire reaction, you can say, goes in the forward direction because we try to generate more and more of those products. Now say the same equation becomes a reversible equation where you can also go in the backward direction, then our entire reaction will happen until our reactants can be equal to the products in their concentration. Now, this state where the reactants become equal to their products, we particularly say this to be an equilibrium. Okay, so I hope you people just remember this much, a brief of what the chapter is. And with that in mind, now let's start the questions. So now the first question, the equilibrium constant of the following are. So you have N2 plus 3H2 gives 2NH3, and for that the equilibrium constant is K1. On the other hand, we have N2 plus O2 gives rise to NO, and that is K2, and H2 plus half O2 gives rise to H2O, that is K3. Now what we are doing is we have to create this equation. Using these three equations, now you have to create this particular equation. Now, while you create that particular equations, now obviously you are making some alterations in this equation. Like if we consider over here, this equation is being reversed. And that is pretty obvious because you see NH3 is in the reactant side over here, right? And over here, even these NO is over here only, H2 is over here only, and you will basically add them and cancel them out. So the point is that you are making multiple changes in these equations, and those changes will also cause changes in this constants that we have over here. Now, keeping all that in mind, you have to just solve this question. So now I hope that a basic approach is in your head about how we are planning to solve this question. And quickly we'll go through the solution. So what happens is we have K1, we have K2, we have K3, right? So firstly, what we are doing is we have to make sure that one equation gets reversed and the other one, we are actually going to just change the things. So what happens over here is we are going to reverse this equation. So this will become negative, right? The first equation. On the second one, you are going to multiply it because now what you want is you want the whole thing to be cancelled, right? So you will multiply it, and likewise the third one you will multiply it, and the second one you'll keep it as such. So what happens is these set of equations actually become 2NH3 gives rise to 3H2 plus N2. Make sense? On then what you have is this part of the equation remains the same. So you have N2 plus O2, and that gives rise to 2NO. And on the other hand, here you have H2 plus half O2 gives rise to H2O. Okay. So now what happens is if you see, we have to make sure firstly that this N is getting cancelled out, which is actually getting cancelled out. So that's not a big deal. Second one, you have to make sure that H2 is getting cancelled out. So for that, you will have to multiply this entire equation by 3. Okay. So then these H and this H will get cancelled out. So finally, if you just add these three equations, you will finally get this equation, right? Sorry. Okay. Let's just do it here. 2NH3 and plus you'll get 1 plus 3 by 2. So that'll give you 5 by 2 O2. And then what will happen is that'll give you 2NO plus 3H2O. Make sense? So that is how you got the equation. Now what happens is over here, if we see, we are actually getting it K1, right? And what is happening over here? Here we are doing nothing. So this remains K2. Now, here you reverse the equation, right? What was your product? That became your reactant. And what was your reactants? That became your product. So now this constant K1 will actually become 1 by K1. All right. K2 will remain as it is. On the third equation, you multiplied 3 everywhere. So your constant here will actually be K3, and you're going to power it with the number you have multiplied. So here it's going to be K3. Now, what do you do after you have added the equations? You just multiply these constants together. So your final constant will become K3 cube times K2 divided by K1, which is exactly what is given over here. Okay. So keeping that in mind, your answer is actually going to be option A. Okay. So I hope that this explanation is clear. This is a very basic application that is even told in the NCERT. Next, which question, sorry, the compound whose aqueous solution has the highest pH is. Now, if we talk about pH scale, right? pH scale starts from 1 and it goes all the way to 14. In the middle, we get 7. And 7 is considered to be the neutral point, right? And is this side towards its left, we consider everything to be acidic. And this side towards its right, we consider everything to be basic. Now, over here, another concept comes of acidic and basic salts. So, what are acidic salts and what are basic salts? So, suppose if I take a strong acid, okay, suppose if I take a strong acid and I make that react with a weak base. Now, when I take a strong acid and I make it react with a weak base, what happens is the strong acid dominates in this entire equation, and the final salt that is formed, that actually tends to be a bit more acidic in nature. Likewise, if we consider the basic salts, so now in the case of basic salt, what happens is we take a strong base, right? And we take a weak acid. Again, the strong base will start dominating your entire equation, and that will result in the formation of a basic salt. Okay. So now if you actually see, all these compounds are salts, right? Salts, which is formed by a acid plus base combination, right? So now your job is to identify which is a strong acid, which is a weak acid, which is a strong base, which is a weak base. And by chance, if you get a combination of strong acid plus weak base, strong acid. So at that point, your salt will become a neutral salt. Okay. So for example, let's take NaCl. So NaCl will be formed with NaOH plus HCl. Sorry, HCl. Okay. So now if you see, NaOH is a strong base. HCl is a strong acid. Make sense? So the salt that will be formed by a strong base and a strong acid is actually a neutral salt. And neutral salt will have a pH of 7. Okay. Now keeping the same things in mind, if we see strong acid, strong base combination, it will be 7. NaHCO3 will be an acidic salt. Hence its pH will be less than 7. Na2CO3 is a salt of a weak acid and a strong base. So its pH is actually more than 7. And ammonium chloride, which is NH4Cl, is again a weak base and a strong acid. Just a minute. Yeah, sorry for that inconvenience. So now you saw that NaCl is a combination of strong acid, strong base. NaHCO3 is a combination of NaHCO3 is a combination of NaOH plus H2CO3, which is carbonic acid. And likewise, we have a weak acid, which is our Na2CO3, okay, and NH4Cl. Now the question comes is that you have NH4Cl is a weak base strong acid. So NH4Cl is an acidic salt. N2CO3 is a weak acid and a strong base. So that is a basic salt. Correct? this is an acidic salt, and this is a neutral salt. And we already saw in our diagram over here that a basic salt will be closer towards 14, right? So that is why the option over here is going to be Na2CO3. Okay. So I hope this question is clear. It was a comparatively simple question. All right. Now find the equilibrium constant of the reaction. The value of the equilibrium constant of this particular reaction is 8. So the equilibrium constant of this reaction, H2 plus I2, will be 2HI. So remember what we did in the question earlier. So suppose if we had this reaction, right? A plus B gives rise to C plus D, and that has an equilibrium constant of K. Then we made it C plus D, and that gave us A plus B. So that became 1 by K. On the same hand, now let's say I multiplied it with 2. So 2C plus 2D gives rise to 2A plus 2B. That will become 1 by K square, right? Just keeping this logic in mind. Now look at this. Initially, you had this equation, okay? And they had this K value. So let's leave the K value for now. Then what you did was you actually just reverse the equation. So that K would become 1 by K. And then if you notice, you have multiplied the entire equation with 2. So then that would just become square. Make sense? That's it. That is what this entire big definition is. But I hope you got the constant, concept over it. You just have 1 by 64. That's your option B. Okay. So I hope that it's clear. It's a very simple question. Okay. Now, for the following equilibrium constants are given. Again, you have a set of equations and you have a thing. Now, the equilibrium constant of oxidations of 2 moles of NH3 to give NO. So now let's just go back. Okay. Let's just go back and remember this equation, right? That is what they're asking. They are literally asking the same thing again, but this time they didn't give this equation. What they did is they just gave the word equation, which is this. Or else, other than that, you see the question is exactly the same question. So this is a repeated question. Okay. Now let's come for this reaction, which is basically the oxidation of ethane, the burning of ethane. Which of the following is not true? The equilibrium constant is given by Kp, which is equal to this and that. Addition of CH4 or O2 at equilibrium will cause the shift to right. The reaction is exothermic, and at equilibrium, the concentrations of H2 and H2O are not equal. Okay, so what happens is that let us talk about writing the equilibrium constants. Okay, and keep in mind that what they are asking us is the not true equations. Okay, so now if we come over here, now you can see that we are talking about the equilibrium constant at pressure, right? And here it is concentrations. So that itself is an incorrect option, right? Because when we are talking about pressure, Kp should actually be equal to P times CO2 divided by P of CH4 and partial pressure of O2. Quite simple. But that is not the case that is happening over here. So obviously this is an incorrect option. Now let's talk about the other option. The reaction is exothermic. Obviously that is what is given over here. So that is correct. We are going to write correct. At equilibrium, the concentrations of H2O and CO2 are not equal, obviously. And addition of CH4 or O2 at equilibrium will cause the reaction to shift right. And that makes sense because you are increasing your reactants. Now to stabilize it and come to equilibrium, we'll always move in the forward direction. So that is a simple problem, which is a very fundamental based problem. Right. Okay. K1 and K2 are the equilibrium constants of reaction 1 and reaction 2. Then, okay, so over here the question seems incomplete. Let's just go to the solution. So what they are asking us is how are K1 and K2 related? Okay, so the question here is then how is K1 and K2 related? Quite a simple question if you ask me, because what we have to do is we have to just calculate the k values of it. Now let's just run quickly on how we calculate the k value for any particular given thing. All right. So suppose now if I have k and I have a plus b, that gives rise to c plus d. So the k of this equation will actually be reactants by products. We saw it in the previous question when we were solving the KP thing, right? So you need to just perform the same thing again. So if I see for equation 1, what I will do is that I will have NO2. Oh, that's NO. So NO, and whatever is the coefficient goes as the power, right? And then you just have N2, and then you just have O2. Makes sense. Now what happens is for the other equation, let us see for equation 2. For equation 2, what do we have? We have is N2 to the power half times O2 to the power half divided by NO to the power half. So let's say that this is K1 and this is K2. Now what happens? You have K1, you have K2. So we can just say that K1 is actually, firstly, you can see they are reciprocated. So 1 by K2. And if we see over here, K2 is reciprocated. And then what we are doing is we are dividing the K2 power by 1 by 2. Right? No, we will square whatever is in K2 and then we will get our particular, sorry, my bad over here. We are squaring it. Just square this and reciprocate this. You will get this. So that makes option A your correct answer. Okay. Now, find the value of Kp in this given equation. You need to remember one thing over here. You're talking about Kp. So you will only consider gas, right? We don't consider the solid parts over here. So if we just keep that in mind, it directly just becomes the option A. Option A becomes your correct answer. And that's what's given over here. Now, if K1 and K2 are the respective equilibrium constants for this reaction, so you have K1 for this and you have K2 for this. The equilibrium constant for this given reaction. Okay, so now what you have is you have this entire equation, which is obviously coming from this equation because we can see that there are some reactions that are happening over here. And basically you have to do this. So again, like we did it in an earlier question, we have 2, 3 equations. We have to come to one final equation. And then in that one final equation, we will just see how are we altering the case. So if I see XeO3F2 is over here, H2O will probably come from this, and HF is coming from here, and XeO4 is over here. So now seeing this equation, I can tell that firstly what I need to do is I need to reverse this equation. So I will just take XeOF4 plus 2HF, and then that would give me H2O plus XeF6. Make sense? I'm going to leave the second equation as it is because we are cancelling it with respect to the first equation. So XeF6, that will give me XeOF4 plus XeO3F2. Okay. Now what we'll do is now we'll perform the cancellings. If we consider the cancelling over here, this will cut with, oh, I'm sorry. This won't cut. XeF4, we need it. XeOF4 will cut on the reactants in the product side, and likewise this will leave. So firstly, I reverse this, so this will become 1 by K1. This is still K. Okay. And then what I'll do is I'll simply just add them. So I'll get XeO4, then I'll get 2HF. That will give me XeO3F2, which is this particular compound, plus it will give me H2O. And now I'll just multiply it. So this will just become K2 by K1. And that's option D. So this is the entire thing written in a much more neater format and a much more easier format. I would say that what they did is they just said what is the representation of K1, and here they have written that what is the representation of K2, considering we have reactants by products. Now what they did was they just saw that if I divide this for this particular equation, this should be my K value. So now how do I alter K1 and how do I alter K2 to get this? Okay. What we did was when we said this thing becomes this, we are actually already considered this thing. Okay, we reverse this equation. So what was the reactants will become the products and what was the products will become the reactants. So automatically you see that this whole thing will get reciprocated, and that is why we get 1 by K1 over here. Okay, I hope you got it. Okay, now let's see this question. So just a minute. Yeah. So now we have if alpha is a fraction of HI dissociated at an equilibrium in the reaction 2HI gives rise to H2 plus I2 starting with 2 moles of HI, then the total number of moles of reactants and products that are present over here. Okay. So here's the thing. Okay. We have a reaction. We have 2HI that gives rise to H2 plus I2. I hope that is the exact thing. Yeah. So now you can see that we are starting with 2 moles of HI. So we'll say that initially at T equal to 0, we are at 2 moles. 2 moles of the reactants, there is no products formed. Okay. Then what happens? Let us say we spend some T times and the reactants start happening. Now alpha is the rate or the fraction at which it is being dissociated. So now what I will happen is 2 into 1 minus alpha will be left over here. Now here is the okay. Suppose I had 1 mole and then that was 0 and 0 initially. Let us say after time t, 0.3 moles went. So I'm left with 0.7 moles and obviously 0.3 plus 0.3 is left over here. Now what I'm telling is consider this thing is alpha. So what we have here, they have told that this is alpha over here, the fraction of HI dissociated. What will be left over here? 1 minus alpha, right? So if for 1 mole that is the case, I had 2 moles initially. So I'll be left with 2 into 1 minus alpha. And here I'll be found with alpha. That is what they're asking. So now let us say this is at equilibrium. T, when I reached equilibrium, T at equilibrium. T at equilibrium. So now what do you have to do? You have to just add it. That's all. Literally, that's all. Because at equilibrium, you have these many moles of HI present, you have this many moles of H2 formed, and you have this many moles of I2 formed. Very simple. So that will be just 2 minus 2 alpha plus alpha plus alpha, and you can see that that cancels out and you're left with 2 moles. So at equilibrium, the total number of moles is actually 2. Quite simple. Oops. Right? So that's 2. Next one. Question number 10. A 20-liter container at 400 Kelvin contains CO2 at a pressure of 0.4 atm and an excess of SrO2. Okay. The volume of the container is now decreased by moving a movable piston fitted in the container. The maximum volume of the container when the pressure of CO2 attains its maximum value will be. Okay. So let's understand this diagrammatically first. Okay. So what do we have is we have a big container. All right. They have told that this is 20 liters. Now, this entire thing is at 400 Kelvin. Okay. Now, what you have is this thing has CO2. So, we'll say that this noodles that I made, this is actually CO2. Now, this CO2 is at a pressure of 0.4 atm. Okay. Now, what happens? There is some solid over here, but they have told that we can particularly neglect it. So, that's fine. Now, what happens is this entire volume, whatever was this initial volume, we are reducing it. And how are we reducing it? We have a piston and we are sending that piston down. That is what they are telling. Now, once you start sending this piston down, obviously first it will come here and here. And you can see that here in the empty area, pressure will increase, obviously, right? So they are asking us, what will be the volume of the container when the pressure of CO2 will reach at its peak or it's at its maximum? That is what the given question is. Okay, so let me just repeat it. You have a big container that is of 20 liters at 400 Kelvin at particular pressure of 0.4 atm. What you did, you attached a piston and you started moving the piston down, because of which the gas inside the container, the pressure of that gas started increasing. So the question is asking, what is going to be the maximum value of the volume of the, sorry, what is going to be the maximum volume, the free space that is available in the container when our CO2 is at its maximum pressure. And they have given us this equation, which we are going to follow along with the Kp of that equation. Okay, so quite simple, right? So now what we are going to do is that we are going to see what is the pressure. So what an assumption here will be that we know that maximum pressure will be at equilibrium. Equilibrium. Maximum pressure will be at equilibrium. And particularly if we see, so Kp will be actually equal to 1.6 atm. And if we see, Kp will be the pressure of CO2 only, because this and this, they are solids. And because they are solids, we have only one gas. So the maximum pressure is at equilibrium, and that maximum pressure is 1.6 atm. So now we have the max pressure value, and that is considered to be 1.6 atm. Then you can use the universal law, PV is equal to nRT. And what you have to do is, now you have to just find the volume at that particular thing. So now you just need to find volume. So that is simple calculation. PV is equal to nRT. N is constant. So what happens is, how did this come? Let me tell you that. So we know PV is equal to nRT, and N is going to be the same at whenever before the piston and after the piston. There's a lot of chaos. I'll write it here. So before the piston, N, let's say, will be equal to piston after. Right? I'll write this. Now, N is over here before and after. So that would be P1 V1 by RT. And here P2 will change, V2 will change, and then you have RT. Now RT will remain constant, so I can just cancel it out. P1 was 0.4 and V1 was 20. P2 will just become 1.6 like we just saw, and then I have to calculate V2. 4, and then that becomes 5. So your V2 is actually coming out to be 5 liters. Quite a simple question. So here the correct option is going to be option D. Okay. I hope that was clear. Next, hydrolysis of sucrose is given by this following reaction. So this is the reaction that sucrose plus H2O gives rise to glucose plus fructose. Those of you who have studied biomolecules, it is a very friendly equation at this point for you then. Now, if equilibrium constant is 2 to into 10 power 13 at 300 Kelvin, find the value of delta G at the same temperature. Okay. So now we know that this is the formula of delta G, right? Now what we have to do is we have to consider this particular formula at equilibrium. And we know that at equilibrium, delta G will actually be equal to 0. Delta G will be equal to 0, not the dot. So delta G will be equal to 0. Okay. And we know that the value of at the same temperature will be. So they are telling that equilibrium constant is there, and hence we are actually identifying that to be equilibrium, at equilibrium. So your delta G becomes 0. Then what you have to do? You just have R, T, Ln and K of the Q. Q is actually your reaction, that thing, equilibrium constant. So I'll just write that. Q is your equilibrium constant. So T is your temperature, and R is basically your constant, which is 8.314 joules per mole per Kelvin. Okay. So now what you have to do is you just need to solve the equation, putting in all the values. So you have 8.3, you have 300, and you are taking ln of K equilibrium. Okay. So I hope then that will just, it's a simple formula, straight off formula. The only thing you have to remember that delta G is actually 0 at equilibrium, and that basically provides you the solution for this question. Okay. Going to the next question. Which of the following conditions will favor maximum formation of products in this particular reaction? Okay. So you have this reaction A2 gives rise to B2, that gives rise to X2. And you can see that it is an exothermic reaction. Now, what we want to do is we want to see that what conditions are favorable so that this reaction will go in this particular direction. Okay. Now, let us see something like this. Okay, let's see like this. Suppose we have a hot place. Okay. And we have a cold place. Right. So now what I will do is that how does heat flow? Heat flows from a hot body to a cold body, right? So it will start going in this direction, hot to cold, hot to cold, hot to cold, right? So one way you can see this, one of the way to do it is firstly that if we want to make this go in this direction, it is an exothermic reaction, then what happens is heat is released, heat will be a lot. So if we have to make it go in this direction, if we cool this place a bit, automatically the reaction will start moving in that direction, right? So that is what you have to remember. So obviously it just becomes a low pressure, low temperature thing. And obviously that is what decreasing, it will shift in the exothermic direction. That is the forward direction. That is what exactly is written over here. Talking about the pressure, pressure will obviously shift in the direction where number of moles are less. It's a very direct relation between pressure and moles, right? Pressure and moles. So it's a very direct relation between pressure and moles. Now, keeping that particular relation in mind, where we have less number of moles, we'll have over here. And so it will become a application of a low constant and a high pressure, right? So that is obviously your option A. Consider the following liquid vapor wave equilibrium. Now, which of the following relations are true? So this is a very simple law, the Calcius-Caprion law equation, and that is this. So it's a thing you have to remember. It's actually not a logical question. All right. Which of the following is correct in a reversible process in the state of equilibrium? Again, guys, we are at equilibrium, so we know that delta G should be equal to 0. So automatically option A and D have gone. And here's the thing, okay, you don't even need to worry about the value because we saw that the equation was what? Oh, just a minute, guys. Forgot to plug in my charger. Yeah. Okay. So we remember that the equation was delta G naught plus RT ln K or Q. Let's write Q. Now, if this sir becomes 0, then automatically this will come this side. And delta G naught will actually become minus RT ln Q, right? That's all. Just because we eliminated that G can't be. Now we have to just see positive or negative. And this equation is literally telling us that it has to be negative. So it's option B. So this question, actually, you didn't need to worry that, oh my God, what is this 2.3 given over here. All right. Next question number 15. Now, for a reversible reaction, N2 plus 3H2 gives rise to 2NH3 and some amount of heat. Now, the equilibrium will shift in the forward direction if we increase the concentration of NH3, if we decrease the pressure, if we decrease the concentration of anything, or by increasing pressure and decreasing temperature. Now, if you actually go, this is exactly this question, right? Literally this question. You have two reactants, you're going to a product side. How do you increase the forward direction? So that, I think then that becomes obvious that we already discussed by increasing the pressure and decreasing the temperature, we can actually make this reversible reaction go in the forward direction. So that's option D, right? Okay. Now, given an exothermic reaction, Kp and K dash P are equilibrium constants at a temperature T1 and T2 respectively. Now, assuming the heat of the reaction is constant in the temperature. So now what we have to check is we have to check if all the Kp's are equal. Okay. So here's the thing. All right. Just let's read this one thing, then I'll explain it to you what's happening. In an exothermic reaction, on increasing temperature, the value of Kp decreases. Okay. So now what's happening is you have a temperature T1, you have a temperature T2. Okay. And you have some reaction. Let us say our reaction is A plus B gives rise to C plus D. And this reaction, my friends, is exothermic. Okay. That means that we are releasing heat. And at temperature T1, we are saying the equilibrium constant is Kp. And at temperature T2, we are saying that the equilibrium constant is Kp dash. Now, assuming the heat of the reaction is constant in this given temperature. So in this temperature, the heat that is being released out, that is constant. Okay. But obviously, these are two different temperatures. And let us assume that in this direction, the temperature is increasing. Okay. So that is exactly what it's telling. As the temperature increases, Kp value decreases, right? So that means that as we are going from this to this, the values are actually decreasing. Does that make sense? So that means that our Kp will actually be equal more than Kp dash, right? And that is what this question is asking us. So Kp is greater than Kp dash. So that's option A. Okay. All right. The reaction quotient of this is given by this. Will this reaction proceed from right? This reaction will proceed from right to left if, okay. So firstly, we need to understand the difference between the reaction quotient and the equilibrium quotient. Okay. So for that, let us assume that we have this equation, our standard equation now. A plus B gives rise to C plus D. Okay. So A plus B is giving rise to C plus D. Now, what happens is your reaction will start. Let us say at T equal to 0, your reaction starts. All right. And let us say that it goes ding, 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 and at T equal to T, the reaction attains equilibrium. Attains. So the reaction is attaining equilibrium at T equal to T. Now, what happens is when we try to calculate this constant, right? The reaction quotient, or the what we say when we calculate the equilibrium constant. Over here, the equilibrium constant will be CD by AB, right? And likewise, it will be over here also, right? CD divided by AB. Now, the catch here is that this was before the equilibrium. Before equilibrium, right? And this is at equilibrium. So obviously these are some different things, right? So the quotient, or you can say this constant, which is not constant because the concentrations are changing, but just so that we can be on the similar terms over here. Okay, this is referred to as Q before the equilibrium. As soon as we attain equilibrium, this is starting to be referred as K. That is what they are telling. So now what they are telling is, when will this reaction start moving from from right to left, meaning in the backward direction, right? So there has to be a state where this reaction starts moving from left to right. And that is exactly what we have to find out. Okay. So I hope that that is correct. So now let's see it in this way. Okay. So you are starting with N2 and you're starting with 3H2. And that is giving you 2NH3. Initially, you have this, so your reaction is moving in a forward direction, in a forward direction, in a forward direction. When will your reaction start moving in the backward direction? When your NH3 concentration will start increasing a lot, right? So if we see, the reaction coefficient is given by this, and similarly Kc will be given by that. But Kc is constant. Why is it constant? Because at equilibrium, these have reached their final concentrations, right? So now what will happen? This will keep continuing after equilibrium, and then at, let's say, t equal to n, it goes out of equilibrium, right? It goes out of equilibrium. That time, let's say we have the maximum number of products. So we have to find at this instance when the product is maximum. That means this value of Q will be more than Kc, because the concentration of NH3 at that point will be more than the concentration that we had during the equilibrium state. It makes sense? Very simple analogy, right? What I'm telling is that, acha, we'll see it here. Okay. I have a reaction, let us say A plus B, that gives rise to C. Okay. What happens is, initially, let's say at t equal to 0, we had A, we had B, but we did not have C. Then some time happened, and then we came to equilibrium. At t equal to T, we are at equilibrium. Okay. At that point, we have A, we have B, we have C, and they are not moving in a forward or in a backward direction, because forward and backward are at equal rates, you can say, right? That is a simple definition of equilibrium. At equilibrium, I'll write at forward and backward are equal. Makes sense? Forward and backward are equal. So now what does this mean? This means that I am at some constant C. Now let us say we continue and we reach at t equal to n, where we have this. We have some amount of this and this. Okay. But this is a lot. Now, because this becomes a lot, we want to maintain equilibrium. We will start moving in the backward direction so that we go back at this situation. Am I right? So in the end, what I'm telling is, for this reaction to happen, once NH3 crosses the concentration it is at equilibrium, it will start moving backwards. That means that at K, whatever is the concentration should be less than whatever is at whatever time we are calculating this Q. And NH3 at Q will be more than Kc at Q. So Q value will be actually greater than Kc. Okay. So I hope that you understood this simple analogy that we have given over here. And let's go to the next question. Okay. So just give me a moment. I'll drink some water. Okay. Now, for the reaction 2BaO2 plus 2BaO gives rise to O2, the delta H is positive. Okay, delta H is positive, meaning we are working with an endothermic reaction. Now, in equilibrium condition, pressure of O2 is dependent on what of these things? Now, if you actually see, the question is pretty straightforward based on whatever we have solved until now. Okay, so let's see a few things. Okay, let's see. We know firstly that our Kp value will be actually equal to just partial pressure of O2, simply because this is solid, this is a solid, and we cannot consider solids when we are calculating Kp. Now, what does the pressure depend on? So now if we see, the equilibrium constant depends only on the partial pressure of O2. And on increasing the temperature, formation of O2 increases, as it is an endothermic reaction. So what they are telling is this reaction is endothermic. And now, because this is in endothermic, that means over here we are absorbing energy. Now, if we are absorbing energy, this will be at low energy, you can say. Now, for that purpose, you have to maintain this place at high energy so that it is always coming here and there is always energy to absorb. Okay, there is always energy to absorb. That means you have to increase the temperature to increase the concentration of O2, right? increase the temperature to increase the concentration of O2. Okay. So that is what we are telling. So now that is literally what this entire reaction is telling about. So the only place you can see that it's not dependent on the mass of all this, it's not dependent on the mass anywhere, because that is not even affecting our thing. What is affecting? The temperature over here. So that is option C. Quite a simple thing, right? They have actually complicated the definition a bit over here, but then that works. Okay. So here I would like to go back to one question. Where did it go? Yeah, this question. So let me just erase this and try to give you this solution from the analogy that we just saw. Okay. Yeah. So this hot and cold analogy, I hope you understood it for this question. The reason why we are coming back to this question is I want to talk about it from the other perspective that we just saw. So here in this question, you can say, so now what they are telling is that we have some reactions. Let me just get a pen. Just a minute. Okay. So what they were telling is we have a reactant A, we have a reactant B, and we have a reactant that gives us C and D, right? Yeah. So I have A2, I have B2, I have X2. Make sense? Now what happens is my reaction is exothermic. And by exothermic, that means I'm releasing a lot of heat over there, right? So at this point, let us denote the heat with orange color. So a lot of heat is being dissociated out in this background, heat energy. So now for it to release heat energy, the surroundings must be cold, logically speaking. Now for the surroundings must be because the surroundings have to be cold, a low temperature is required. Okay. So now as the reaction is exothermic, a lot of heat is released or a lot of energy is released. Lot of heat slash energy is released. Now, if a lot of heat and energy is released, that is therefore the surroundings must be cold so that we can release the energy. Make sense? And for that purposes, we can say that because of this, therefore, we require a lower temperature. A lower temperature. Make sense? So a low temperature is one of the reasons. That is this and this. Now we have to talk about pressure. Now, let us talk about the pressure. Okay. So what is happening over here? If we just go over there, we know that this is there and then this continue. Okay, we'll just restart this question quickly. So एक equation है, we have one equation a2 plus b2 gives rise to x2 and then this is that equation and they have told that this is an exothermic reaction that is over here. That means energy is released. So to absorb that energy in surroundings, we know that the temperature right? So the temperature present over here. So for that particular thing, you can say that we need high
आदित्य नहीं 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 बहुत ब्रेक हो रहा है वी कैनॉट अंडरस्टैंड एनीथिंग कुछ भी समझ में नहीं आ रहा अच्छा आप एक काम कर लो आप ना किसी एक मोबाइल पे भी ना आप लॉग इन करके देख लो आप जब पढ़ा रहे हो तो वॉइस कितनी ज्यादा ब्रेक हो रही है आपको उस मोबाइल से समझ में आ जाएगा आप किसी मोबाइल पे ना लॉग इन कर लो जूम आईडी एंड उसको म्यूट करके रख लो अपने पास तो जब भी ब्रेक होगी तो आपको आइडिया लग जाएगा कि ब्रेक हो रही है